Okay, now last class we did quantum numbers. अभी थोड़ा आगे continue करते हैं. What we have to study today is the shape of atomic orbitals. Before we directly jump into the shape of atomic orbitals, हमको ये समझना है कि ये shapes आए कहाँ से. Now, can someone tell me what was psi? Wave function या amplitude of the wave. हम वेव फंक्शन भी बोलते हैं साई को. And people go to psi squared probability density function. What was probability density का meaning? The probability to find an electron in a particular region. In better terms, to find the probability to find an electron in particular volume. हम उसको जब हम probability density curve बनाएंगे तब थोड़ा volume से भी equate करेंगे. Now, when this was mathematically solved, so what was observed is, in case of S subshell, I repeat, जब इसको solve किया था हमने mathematically, ठीक है, this is your x-axis, this is your y-axis. Center origin पे it's the nucleus. When this was solved mathematically, every dot that you see is the probability that वहां पे कौन present था? Electron. This is all mathematically. It was also later proved experimentally. And what was done is, if you try to bring maximum number of dots within one particular region, for example, I'll try to bring in maximum number of dots in one particular region. What is the shape that you get? Sphere. You get a 3 dimension पे. ये तो circle दिखता है. But in 3 dimension, what do you get? You get a sphere. This is the shape of the S subshell. What's the shape of the S subshell, people? It is spherical. Not only that, this was done for a uni-electron system. For H, hydrogen के लिए किया. You know how much ये value आया? Like यहाँ से यहाँ तक का this particular value 0.53529 angstrom. What value is this? Given by Bohr. Again, mathematically proved by Schrodinger's equation that Bohr was correct. His hydrogen atom के जो radius का formula derive किया था mathematically, that was correct. Did you people get that? ठीक है, it's something really extraordinary. Bohr ने तो सिर्फ mathematically तभी proof किया था. Eventually, when quantum mechanics है, when Schrodinger's equation came, and when psi square से plotting हुआ, the radius was 0.529, which exactly matches the Bohr's radius वाला formula. Did you people get that? Again, there are also experimental proof for this. Experimentally भी ये shape observe होता है. ठीक है? So, if I ask what's the shape of the subshell, all S subshell का shape क्या है, people? Spherical. ऐसे बना सकते हैं, और where you have x axis, यहाँ पे people y axis, और यहाँ पे coming out from the board will be z axis, x y and center में क्या है people? Nucleus. Now in S subshell the maximum probability to find the electron is near the nucleus. I repeat, the maximum probability to find the electron is near the nucleus. You can also see that by the probability density plot. न्यूक्लियस से जैसे आप दूर गए, कैन यू सी वो डॉट्स भी थोड़ा थोड़ा कम होने लगे. As you move away from the nucleus, the density of the dots reduced. इधर तक with me? Something more. How many orientations are there in the S subshell? जब हमने वो पढ़ा था in one. Why do we say it's one orientation? Because it's a sphere. तो x axis की टाइप जो रेडियस है उतना ही y axis की तरफ है, and obviously उतना ही. So it's not that the orientation is more along the x axis, less along the y axis, and like moderate along the z axis. ऐसा नहीं है, which we will study in the next orbital that we do. So जो orientation x axis की तरफ है वही orientation along y axis and वही orientation around z axis है. We again come back. हमने हाइजेनबर्ग के टाइम किया था. You want to visualize how a hydrogen atom is according to quantum mechanics. एक स्फीयर इमेजिन करो. स्फीयर के बीच में कौन है? न्यूक्लियस. And where is the electron? Can you find its precise position and velocity? No, but you know that it is somewhere. न्यूक्लियस को थोड़ा बड़ा बना देता हूं. We don't know where it is, but we know that it is present somewhere inside that particular region. समझा इधर तक? This is the shape of S subshell. S के बाद कौन आता है people? P subshell. How many orientations are there in the P subshell? There are 3 orientation. -1, 0, +1. Since there are 3 orientation, the 3 orientations are Px, which means it's along the x-axis. Py, मतलब it is along the, and Pz, मतलब which is along the z-axis. And the shape for P subshell is something like this. This is along कौन सा एक्सिस बनाया people? X axis. This is also Z axis, पर वो मैं बना नहीं रहा हूँ. You want to imagine a P subshell, take a balloon, ठीक है, similar balloon लो, उनके opposite ends join करो, तो वो कुछ opposite ends join किया तो balloon कुछ ऐसे दिखेंगे. I repeat, opposite ends of the balloon you have joined. P subshell, Px would look something like that. And you want to imagine electrons, तो अंदर ना वो thermocol balls डाल दो, and थोड़ा सा move करो and then join करो. Imagine thermocol balls moving randomly somewhere, but within the same region. That is P subshell. P subshell के shape को हम बोलते हैं dumbbell. Where is the nucleus? Origin पे. But where is the maximum probability to find the electron? The maximum probability to find the electron is not near the nucleus. It's actually away from the nucleus. Maximum probability to find the electron is here. And the minimum probability to find the electron is near the nucleus. वो जो लोब पतला हो रहा है ना, thinning down of the lobe is mathematically, it correlates to that. The probability to find the electron decreases as you move closer to the, इसलिए वो area है ना, वो as it reaches close to the nucleus, वो area कम होने लगता है. It's more away from the nucleus, and let's say if the nucleus is somewhere over here, the area decreases. With me till here? So, maximum probability to find the electron is away from the nucleus. Px इसलिए बोलते हैं because this is oriented along the x-axis. Py इसलिए इसको बोलते हैं because this is oriented along the z-axis. Sorry, y-axis. And this will be called as Pz because this is oriented along the z-axis. Imagine z-axis is like something coming out of the board towards you people. ये आपका y-axis है, ये आपका x-axis है, and z-axis comes out of the board. Three orientations. Did you people get that? Any questions still here? Next, which is the orbital after this? Which is the subshell after this? D. D subshell has how many orientations? I repeat, D subshell has how many orientations? 5 orientations. The orientations are called as first dxy, second dyz, third dxz, fourth dx squared minus y squared, and the last orientation is dz squared. Shape. This is x-axis, this is y-axis. The shape here is something like this. Same lobes, but they are in between the axis. And since there are two lobes each, the shape is called as double dumbbell. ठीक है? This is xy because it's along the x-axis and y-axis. The same shape is for yz. Only difference is axis change. यहाँ पे axis is y-axis and z-axis. This is called as xz. So this is x-axis and z-axis. Axis change किया है. I'll also try to show you थोड़ा सा better shapes online. Next, dx square minus y square. Shape is same, but instead of being in between the axis, it is present along the axis. And the last orientation that we have is dz square. Dz square looks something like this. This is x-axis, this is z-axis. The lobe here, which looks like a medu vada or a donut, is along the x-axis and y-axis. And this lobe here is along the z-axis. dz square is also known as donut shaped. The upper three, dxy, dyz and dzxz, are known as in between the axis orbitals. एक और नाम याद रखना, which will be required in 12th standard. इनको हम बोलते हैं T2G. The below bottom two, they are called as along the axis orbitals. Also known as EG. These are the different shapes. F has how many orientation? 7. But F ka shapes are out of scope. They're not there in our syllabus. Photo, however, dikha dunga, but you don't need to really study them. Did you people get this? Samjha ye? Chalo. So quickly copy or write on a new page. Shape of atomic orbitals and start copying this. The next topic that we have, people, is called as nodes. Now, what do you mean by nodes? Nodes is a region in space where the probability to find an electron I repeat, it's the region in space where the probability to find an electron is 0. Nodes are also called as, they are also called as anti-orbitals. चलो, इसका मतलब क्या? लेट्स ट्राई एंड अंडरस्टैंड दैट. एस सबशेल का शेप क्या था पीपल? व्हाट वाज द शेप ऑफ द एस सबशेल? Spherical. So let's say I want to make, though I'm making a circle, remember, okay, the shape is spherical. Let's say this is 1s. If कौन सा orbital है? This is 1s. What comes after 1s? 2s. 1s का shape क्या है? So obviously 2s का भी shape क्या है? Spherical. So imagine हमारे पास 2s है. Now it's obvious that 1s is within 2s. बीच में न्यूक्लियस है, पहले 1s आएगा and then 2s. What was observed is that remember center में is the nucleus, x-axis, y-axis and z-axis. This is your nucleus. So 1s के electrons somewhere in this region. I repeat, this is 1s. Between 1s and this is 2s, what was observed is there is a region in space. ये जो region है, ये region में there are no electrons. So 1s के electrons, nucleus, electrons present in 1s, a particular region जो मैंने red highlight किया, there are no electrons, and then again it was observed that there is a probability to find an electron. This region between 1s and 2s, where there was no electrons found or observed, ये region को हम क्या बोलते हैं? Node. Can someone tell me the shape of this node? Even that is spherical in shape. इसलिए हम उसको बोलते हैं spherical node, or we also call it as a radial node. So what is a node? A region in space where the probability to find the electron is 0. What is actually 0 is आपका wave function and आपका probability density function becomes 0. When psi is 0, psi square will obviously be 0. We say that we have found a node. What is the type of node? हमने क्या लिखा है यहाँ पे? It's called a spherical node or radial node. It is because wave function is divided into two parts. Wave function के एक part को हम बोलते हैं radial part of the wave function, and there is another part of the wave function जिसको हम बोलते हैं the angular part of the wave function. Radial part, angular part, theta and phi. It's obvious because in simple terms इसका कुछ radius होगा, और I can say that the first node जो मेरे को मिला है, it is at a particular r distance from the nucleus. You can find that distance. Angular nodes is for these lobes, because these lobes are at an angle from the axis. For example, you people can give me this angle. If I ask the angle over here, what is the approximate angle that this lobe is making with the xy axis? 45 degrees. So you can find nodes either with reference to radial part of the node, radial part of the wave function, or the angular part of the wave function. Did you people get that? So radial nodes are given by the formula radial, या हम उसको बोलते हैं spherical node, is given by the formula n minus l minus 1, where n stands for principal quantum number, L stands for azimuthal quantum number, and the second type of node जिनको हम बोलते हैं angular node, or they are called as planar nodes, which is given by the formula L, azimuthal quantum number, because L or azimuthal quantum number represents the angular part of the wave function. So if I want to know for 1s, 2s, 3s, can someone tell me how many radial nodes are there, how many angular nodes are there? दोनों का सम करो तो क्या मिल जाएगा? Total number of nodes. Formula n minus l minus 1. What is n for 1s? 1. So 1 minus, what is l? 0. So 1 minus 0 minus 1. So number of radial node in 1s? 0. Angular node? Why? Because angular node is given by L. Total number of nodes is given by the formula. इन दोनों को ऐड कर दो, n minus l minus 1 plus l. यहाँ पे भी तो टोटल आने वाला है. What about 2s? 0. Anyone who did not get that कि ये 1 कहाँ से आया? 2s. So what is the value of n? 2. What is the value of l for s subshell? So 2 minus 0 minus 1. You want me to write that in detail over here? 2 minus 0 minus 1. तो कितना हो जाएगा वो? This will be 3 minus 0 minus 1. How much is that? Will the S subshell have any angular node? Total number of nodes? 2. Did you people get that? Yes or no? No. When you go to P subshell, now यहाँ पे visualization is important. When you go to P subshell, how many orientations were there for P subshell? 3. Which were the 3 orientations? Px, Py, Pz. इससे start करते हैं Px. So आपका lobe is along the x-axis, which means the probability to find an electron is along that axis. Ab, if I draw a plane like this, which is the YZ plane, so the probability to find the electron is 0 along the YZ axis. Let's try and understand this again. ये आपका लोब है, ठीक है? Which is along which axis? X axis. अगर थोड़ा ऊपर देख ले, so this is which axis? So ये लोब X axis और Y axis में आता है. So electron ये region में if I try to find an electron along this region, the probability to find the electron along this region is 0. In short, Px है, so the node is present along which plane? YZ. If it is Py, then the nodal plane is XZ. If it is PZ, then the node is along XY. Did you people get that? I repeat. जहाँ पे भी lobes बनाए वहाँ पे nodes भी add कर देना. So for Px, which is the nodal plane? It is along YZ. For Py, where is the nodal plane? It is along XZ. And for PZ, where is the nodal plane? Is along. Other formulas remain the same. For example, I have 2p, 3p and 4p. Give me the number of radial nodes. Give me the number of angular nodes. And give me the number of total nodes. What is the formula for radial nodes? N minus L minus 1. N का value क्या है यहाँ पे? 2. What is the value of L for P subshell? 1. तो क्या formula आएगा? N minus L minus 1. This will be 2 minus 0. 3 minus, how much is that? 4 minus angular node. Total number of nodes 1. 1 plus 1. 2 plus 1. We'll again come back to this next lecture, mein. So this was for P subshell. Next we have D subshell. Which were the different orientations for D subshell? dxy, dyz, dxz, dx square minus y square and dz square. We start with dxy. If you look at dxy, electrons are present along the xy plane. Which axis is missing? Which axis is missing? So इसका nodal plane कहाँ है? XZ and YZ. If you look at DYZ, which axis is missing? So give me the nodal plane. XY and give me the nodal plane for DXZ. XY and YZ. समझा इन तीनों के लिए? Yes or no? However, when you look at dx square minus y square and dz square, the node is not along the axis जैसे यहाँ पे बनाया था, because the lobe is along the axis. So your nodes are present like this at an angle of 45 degrees. So the nodal plane is present at an axis of 45 degrees. And last, when we look at dz square, the node is in the shape of a cone. Conical node, an angle of 45 degrees. If you want to visualize these, इसलिए मैंने वो ये वो cone है where the probability to find the electron is 0. And these are the different nodal planes. Did you people get that? Chalo. I have 3D, 4D, 5D, 4F, 5F. Give me the number of radial nodes. Give me the number of angular nodes and quickly give me the number of total number of nodes. Radial node का formula क्या था? n minus l minus 1. Angular node का formula क्या था? Total number of nodes 3D. 3 minus 2 minus 1 क्या हो जाएगा? 0. Angular node 2 2 2 3. चलो 4D 4 minus 2 minus 1. How much is that? 5D 5 minus 2 minus 1 2. 4F 4 minus 3 minus 1 0. 5 minus total number of nodes
2, 3, 4, 3, 4.
That's it. That completes nodes. We stop here for the day. Next class we will complete probability density curves. Hopefully we'll finish the chapter next class. ठीक है? Sure. Thank you. Hello.